2212 Lab 2 about charge tape continued. So the purpose of this lab was to estimate the charge needed on each tape to float one above the other by distributing charge across the length of the tape in a computational model. And the models we used were Newton's second law, which is force equals mass times acceleration, the electric field formula, which can be seen, and Newton's third law, every action has an equal and opposite reaction. So, to preview, the results of the lab were different from the first lab, where we estimated the charges as point charges, and the difference was a factor of about 2, a little bigger than 2. And the charge on the top piece of tape is roughly 2.2 times 10 to the negative 8th coulombs, based on the results from this lab. So, as the initial conditions, the system was the upper charge tape, surroundings was the lower charge tape, and everything else. The tape length was 0.2 meters, and the tape mass was 0.2 thousandths kilograms, and the gravity was the gravitational constant negative 9.8 meters per second squared. So, as a recap of the experiment, I got 2 pieces of tape, and basically we floated one above the other, and we measured the distance between them that they needed to be to float. And then this is my code here. So you can see all of this. This is already here. I put my distance in there, and then I put my point charge here. Just commented that so I could compare that charge and this charge here. The charge on line 16 is the one I had changed to estimate and figure out what the answer was for the charge on that tape. I found the mass here, gravitational force, electric force, and then I defined my electric field here. So you can see my calculations just calculated R, the magnitude of R hat, and then the electric field. Alright, and this was already here, we didn't edit that. And then all I did here is I put my top tape a distance of D above the bottom tape. That's all I changed there. And then I just changed the scale till it looked right. Same with the scale here. And that's mostly it for this. Yeah, that's everything I changed except for just like a couple things down here. Alright, so for the discussion, what was the magnitude of the charge on one piece of tape? And that is 2.2 times 10 to the negative 8th coulombs. What assumptions, approximations, or ideations did I have? I assumed that the tapes are made of lots of small point charges. I also assumed that all external forces besides gravity were negligible. I assumed that the tapes were perfectly parallel to each other. And I also assumed the tapes had equal magnitudes of charges on them. So for the what if question, what if you had modeled each of your tapes as a single point charge like in the previous lab, and compare the values? So the estimate for the point charge was 9.34 times 10 to the negative 9th coulombs, and the estimate for the charge of this line charge was 2.21 times 10 to the negative 8th coulombs. So they're not extremely far off from one another, just like a factor of like 2 or 2.5. So why do these estimates differ? Which value is likely to be closer to the real value and why? Well, these values differ because the line charge model was more accurate, and the reason is because the line charge model represents what was actually happening in real life more accurately, because in real life it wasn't just a point charge, it was a line charge. And in this scenario, we treat it more like an integral than just a point charge because we use several point charges to make this line charge. So as a conclusion, it is more accurate to code this as a line charge rather than a point charge. And yeah, thank you for watching my lab. If you have any questions, feel free to comment them on Perusal since we're fancy now, and I'll definitely answer them for you. So thank you.